Hello, in this video I will be talking about a process I call tile streaming on the Game Boy. And what this involves is, rather than having the normal sort of tile set only, you would break up your background images into small parts, which you would then copy into the 256 background tile area as and when you kind of needed it. As an example here, you can think of this as like this would be tile 1 in the tile memory, and maybe you've got an animation sequence that won't fit in at all the other sort of locations. So rather than load all these frames in and take up 4 frames, we can just copy individual tile data from ROM over into that one tile, and then update where we copy from every sort of frame, and then change it as and when needed. So we kind of stream it across. What this will actually do is any of tile 1 which are actually on the screen, when you stream the new data, after the screen is refreshed, all of tile 1 on the screen will simultaneously change to the new image. So it can be thought of as a good animation effect. So you don't have to have all of these frames in memory at any one time. You literally copy across them as and when you want to change the image. So I'll give you an example here. So there's only 256 background tiles on the Game Boy. So we kind of need to create areas or regions of these tiles alone that we can change. So I kind of keep this area here from tile 48 to tile like 96 as an area for your font set, but you only really need a font set for like the title screen. After that you can just really stream in a whole load of new tiles for the backdrop for that level or whatever. There's no point keeping these there if they're not going to be used throughout the game. The numbers you might want to keep in place, but you could probably totally overwrite everything else here as and when the game sort of progressed. So some pros of this approach is that it gives up more possibilities for graphics in the game than what the Game Boy can hold at any one time. The cons of this are it obviously takes time to stream, or rather copy, the new tile data to the new areas it needs to overwrite. I will explain all this graphically via an example as we sort of go further, but first off I will talk about the graphics here for the example. So in this image here, there is no reason to load all of these tiles in. So you can think of the image here with all of our tiles as being separate from what's actually in the video memory, or rather the tile memory of the Game Boy. For example, this tile here obviously is the empty tile. These 4 tiles here these are just placeholders for this graphics here. So these are the floors of our scene. If I bring across an image a minute, you'll be able to see where I'm going with this. So this is my mock-up scene for the next game I will be putting out, which will be this is the Game Boy version of it. Rather than you dropping bombs on buildings, there's a load of carnivorous plants that you need to get rid of. So you'll be flying Marco here, our character, in his plane to drop bombs to clear a path of these dangerous plants. So the plan is to have a number of different floors. So these are the floors here, but these change per level. So rather than have to keep drawing different parts, all I will do is stream these to the tile memory. Tiles 1 and 2 will hold the 2 tiles for each floor, and then level 4 will have a dynamic floor. So these tiles here will be streamed as the game is running to create an effect, an animation if you like. So this is like a bridge, and this is water under that bridge. So by streaming one tile every couple of frames, overwriting one of these floor tiles here, this will update the screen display everywhere the floor tiles are actually drawn. And then these are the various parts of the plants here, but I will not be these will not live in the same place in tile memory as they are in this image here. I will only be copying parts from this image to these couple of places actually in the tile map, or tile memory, sorry. It probably would have been better if I'd broken these into separate little images for you, which would have made it easier to sort of see. So these are the actual parts here for the plants. This is it obviously split up. So you can think of, if this was the in-memory tiles, we need 4 for each part of the animation of the head. And then we only stream in 1 frame into 4 of these when we want to animate. So I will now show the example, which will probably clear everything up. It's hard to kind of explain these things here. So I will now jump into the code. So first I'll show you the program running here. So here's our Marco. This is a sprite here moving, and then this is the effect of tile streaming every couple of frames. So it looks like we've got parallax scrolling happening here. Maybe these are in the background and these are in the foreground. And then these here are actually being streamed as well. This is not separate sort of like tile parts being put in. If I show you the tile viewer, this might help. So as you can see by looking at this, these tiles are animating, and that's because we're tile streaming in the data to these few regions here. Same with the floor, we've got the two floor tiles there, but as you can see they appear to be animating in the actual tile memory. That's the effect of all of this. I didn't really need to load in all of these here. So now that I've showed that, let's jump into the code and I will be able to explain things a lot better here, hopefully. So there's no new things here. So there aren't any new sort of commands we're going through here. All we're doing is copying the tile data. So this is the graphics for all of our tiles here. Now whilst I did copy all of this across, there was no need to copy everything. So this is the key part here. So we've got 176 tiles. Each tile is made of 16 bytes. So to be able to stream or update that tile, we need to know where it lives in our array of data. And then, so this is kind of this is our source, if you like, if we were to do like a memory copy, and the destination location would be the tile in the tile memory. So while this here records where the tiles are located, you'll see to draw these things we only have one allocated ID for it, which is number 1 for the floor. These allocate only 3 sort of frames as well. So going back to this now. So to animate the vine heads, first we draw them. This just sets up the drawing part here. They're only actually drawn once. So when you draw these tiles onto the screen, you don't need to touch them again. When you stream new data into tile memory, it automatically updates those tiles on the screen with the new graphics. So to do the tile streaming for the heads of the vines, what we need is an offset and a destination for our graphics pointers here. So what we first need to do is we need to get to the tile location in our array of a vine's head. So all this is doing here, we're only updating one type of tile or one of the vine's heads each animation cycle. So if we change the graphic in memory of that head there, then all of those head frames will then be redrawn automatically with the new data that we copy to that location here. So we have an ID here in this example which controls which vine is the one to be drawn to next. So there's 3 head types, as you can see there, 1, 2 and 3. So we have the position offset of where this actually is in our array, and then we have the destination tile offset. So the destination tile offset is where in the tile memory it actually is, because if you remember, our set tile data function here takes the tile ID and how many tiles we're going to write, and then it takes a pointer to our array of data to copy. So what this does here is it takes the starting tile, the actual tile ID, and then using a bit shift here, it multiplies it by 16, as there are 16 bytes per tile. So if I open this here up, so head 1 is located at tile 128. So we need to get the starting location of this in our graphics array here. I'm probably going to need to open up the tile set again to keep cross-referencing this to show you, so we can all of it sounds more complicated than it actually is. The difficult part is trying to explain it so that it will make sense and you can actually use it. So this is tile 128 right here, that's 129, that's 130, and that's 131. As you can see, all of the animation frames, which are these frames here. So this is our tile data. So for every copy that we need to do, we first need to have the starting tile, then times it by 16 to get to the right byte in our array, and then in our destination number here, this is where we're going to write that tile data to. So first we set the starting position for each of the tile heads depending on which one is active. Now this bit here we have to add then to this the offset. So this variable here, vine head, this is the actual frame. So if I bring in the other one again, so vine head can only be 0 to 3. So to go from this frame to that frame, we have to add 4 tiles worth of bytes. So from here to here is actually 64 bytes, because 64 bytes make up one of these frames. Hence we add, or rather we multiply the vine head by 64. Then we get the offset of the array and then copy that data then to the actual tiles in memory. So let's go over the floor scrolling. Might be a bit easier to kind of explain over, maybe not. So in this example we're only drawing these here. Now if I show you the drawing of the floor here, we're only drawing this tile here. So screen width is obviously 20 tiles on the Game Boy. And this is tile 1. So there are 8 of these here. So this is the main loop here. There's not a lot to this. There's not a lot to this. There's timers. There's 3 timers here which control the updates of all of the different stuff. So Marco flies at 1 timed interval, and then the floor scrolls at another, and then the vines animate at another again. So the first timer for the floor scroll, all the floor scroll does is when that timer reaches 0, it changes the tiles. This one doesn't even, this one. So we're drawing, this command here draws 2 tiles at a time. And then we're copying 2 tiles. So the position offset there, as you can see, is in steps of 16 again. So we're using this position offset again. The dynamic floor variable controls which tile we're copying. And then first off we get the starting location in the array, which is this here, which is this tile here. This is tile 16, 17, 18, 19, 20, 21, 22. So this is where we start, and then we first copy these 2 tiles into here, and then we're literally copying in steps of 2 here. But what you'll notice is we copy the same tile to both of those 2 locations there. So we have the starting offset into our tile array, and then depending on the the dynamic floor value can only be 0 to 7. If it equals 8, then it wraps back round to 0, and then we times the floor value by 16 and add that to the starting location. We then get the data starting point into P tile here, and then copy that into the 2 floor tiles, thus creating a false sense of animation. So if you had like a whole background of a couple of tiles, then you could create the illusion of animation by just streaming some images to those tile locations. Hopefully this kind of makes sense. So everything is only drawn once background wise. When you copy over a tile's data in tile memory, you instantly change all images of that on the actual screen. So it's kind of like a nice cheap way of animating loads of different parts of the screen at the same time while using less in the way of tiles to do so. If you've got any sort of questions on this, then leave them in the comments below. I'll post a link to this demo which I will upload. If you're not sure of this, then just go in and have a play around with things until it kind of makes sense. Everything else in here I've covered in other videos, whether it's about sprites or not. I haven't really done anything more in here, I don't think. Only bits I have sort of changed here is I've added in some more sort of constants for when to hide parts. Right, that's it for this video. The next Game Boy one will hopefully be the finished Plant Blitz game using all of this. Okay, that's it for this video.